So we sometimes talk about the hominins as a tribe, and by tribe what we mean by that is that there are several different related species and genera that kind of go together, and they're basically all these smart bipedal kind of hunter-gatherer apes. And among them that includes several different genera. Your book talked about this. Probably the most one of the most conventional ways of splitting them up is the Ardipithecus, Australopithecus, Paranthropus, and Homo. And Homo is the genus, the sort of group of species from which we have Homo sapiens, aka humans, which the difference between us and the other hominins are we are really smart, really bipedal hunter-gatherers with very rad tools. Now there are about 12 at least species of hominins, and actually probably more than that, and we're discovering more continually. And as you go along, one of the big differences that you'll see between the different species, this sort of makes humans humans and makes the Homo genus different from the other ones, is much larger brain size. That's not always the case, but that is often the case. So in this graph, one of the things you'll see is when these different species arose over time. And as you'll see, you kind of have things like Australopithecus coming first, sort of several million years ago. And actually this doesn't really go back far enough. It potentially goes as far back as 6 or 7 million years ago. And then you have sort of things from the genus Homo, which is where Homo sapiens comes from, arising around 2 million years ago. And then especially 1 million years ago, that really picking up, and eventually Homo sapiens within the last few 100,000 years. So as we look at hominins, we see some interesting characteristics, one of which is, again, bipedalism. That's really what makes hominids hominids. At some point, the common ancestors of bonobos, chimpanzees, and hominins split apart, and you had the hominins take off in the direction of bipedalism. And bipedalism is intrinsic to how hominids across time have made a living, from hunting, from scavenging, from different things. Bipedalism allows for a lot of things. It allows that long-distance hunting kind of methods we've talked about. It also allows for food carrying. So some anthropologists are of the opinion that the earliest hominids would have been scavengers of meat rather than hunters of meat, but it allows for that too, right? You can pick up the meat and take it back. It also allows for gendered divisions of labor, where the males go and scavenge food and then bring it back to females who can be raising the children back at the settlement, which is not to say that the mothers wouldn't also have been hunting, but potentially hunting smaller things or different things closer at hand. And so that then allows for and contributes to the human tendency, the hominin tendency to have very long periods of infant dependency, where infants take a long time to learn from their mothers and need to be cared for a long time. So these things all kind of fit together, right? Bipedalism also allows potentially the ability to scan the savanna, which is what we originally thought the original human habitat would have been, although now we're thinking more that it probably was kind of mixed forest/savanna with some trees, some grassland. It also allows tool use, the ability to carry tools. So bipedalism has a whole lot of great qualities. On the other hand, some not so great qualities. This ridiculous drawing with lightning coming out of that person's back is to symbolize the fact that we have a lot of skeletal stress on our bodies as a result of being bipedal. All our weight kind of gets centralized rather than being distributed across 4 limbs. So this is, and then we also have to have a certain kind of way that our legs are positioned to allow us to efficiently walk on 2 legs. I mean, chimps and gorillas and things can walk on 2 legs, but we're talking about efficiently walking on 2 legs, at least gorillas can stand on 2 legs. Anyways, we do so efficiently, though. We do it habitually. That's our main form of locomotion, but that causes a lot of stress on our skeleton. It's also easier to spot if you're trying to avoid becoming a, saber-toothed tiger meal. And so it comes with some balances and trade-offs, but that's true of all things in terms of evolution. There's always these trade-offs, and apparently the benefits outweighed the costs, so hominins went in the direction of bipedalism. They also went in the direction of their brain capacity increasing dramatically over time, with the more recent hominins, such as, let's say, Homo neanderthalis or Homo erectus, having a brain capacity that was several times over what a chimp's cranial capacity is. So the unit we use to measure that is cc, or cubic centimeters, and what we find is that humans have the largest cubic centimeter, with an average around 14 to 1500 for an average adult human being of our cranial capacity, which roughly translates to our brain capacity. Now, it's not all about the size of the brain, it's also about the complexity of the brain, the flexibility of the brain, but humans excel in this also. But certainly, since we can't, go back and scoop out the brain from an Australopithecus, we have to kind of rely on skull size as one of our main ways of determining what was going on as far as their mental development over time. So humans are definitely the leader in this regard, but we can see that it's been a progression over time, with hominins having larger and larger. Generally speaking, this wasn't just sort of a one-to-one thing, but sort of a general progression towards larger and larger brain sizes, both larger in absolute terms, like literally larger, moving from 300 for the Australopitheci all the way up to sort of 1500 for modern Homo sapiens, but also larger relative to the body size, meaning it's not just that our brains are bigger, it's also that even if you take into account the fact that a human's a lot bigger than a chimp and a human's a lot bigger than an Australopithecus, our brains, relatively speaking, are still quite a bit larger. So if you take some of the earliest hominins, such as Australopithecus afarensis, what we sometimes call the Lucy skeleton, for example, that was found in the 70s, and that's about 550 cubic centimeters. The modern humans are about 3 times that, so it's been a progression of larger and larger and larger brains. Why does this matter? It matters for a lot of reasons, among which what we see is that the species is starting to evolve, the hominids are starting to evolve in a direction of culture, right? They're getting larger and larger brains that will allow them to develop things like unique language. It's not that other animals don't communicate with each other, they certainly do. But human language, as we'll talk about throughout this course, is very interesting and very unique, among other things because of its openness and its displacement. In other words, it is very, very malleable, and we can use it to talk about all sorts of things, even things that are not immediately present. We have the ability to say things that are more complicated than just, hey, there's food here, hey, there's an enemy here, hey, it's time for mating. Human language is infinitely more complex than our ape relatives. And so as we see brains getting bigger and bigger, it's allowing the hominins to develop language. It's allowing hominins to develop culture. It's developing and cooperation and all the things that make humans humans. So culture overtakes biology as the limiting factor, by which I mean humans start being able to explode into new niches. We start being able to develop new ways of making a living. Oh, we're going to be hunters now. Now we're going to be fishers. Now we're going to live in the Arctic. Now we're going to eventually develop agriculture. It's so suddenly, unlike other animals, we're not limited by our instincts. We're not limited by sort of what habitat evolution puts us in. We're now really limited by the degree to which we can develop new ways of making a living. And to the extent that human beings have been able to do that over time, we've spread across essentially the entire globe. So the hominin progression then is one of increasing brain size, and one where bipedalism has become very important. Now earlier I had a slide where I said that we might think of the hominins less as a family tree and more as a family shrub, because we tend to think, if you look at a chart like, let me see if I can find it, this one, we sometimes have this idea of sort of humans developing, like this thing became this thing, became this thing, became this thing, and then you had humans. But really that's not what the fossil record tells us. The fossil record tells us instead that you had a whole lot of different species, some of which did eventually, some of which eventually do become modern Homo, including Homo sapiens, at least as far as physical anthropology tells us, but others of which went in totally different directions and then eventually died out. So it's a shrub rather than a tree. It's a bunch of lines that go in different directions rather than one straight line. But even though that's the case, we can still chart some general progression. So let's talk about progression of hominins. So the earliest hominids have been carbon dated, that would be potassium argon dated, as well as with other methods, to be 4 to 7 million years ago, maybe. So there's a bunch of species like Sahelanthropus, Aurorin, Ardipithecus, found in East Africa, which are kind of existing 4 to 7 million years ago, and may or may not be ancestral to modern humans. You have Australopithecus 4.2 to 1 million years ago, which definitely are included are considered to be part of sort of the human family tree or human family shrub, the lineage. And you have species like Australopithecine africanus, Australopithecine afarensis. I do not require you to, I'm not going to have you go super into depth with this. I do want you to understand in very broad terms. These were smaller than modern human beings, or at least smaller than most modern human beings. So the largest of these Australopithecine species was like 100 pounds and 5 feet tall, from what we can tell. They probably eventually led to the Homo erectus, Homo neanderthalis, and Homo sapiens, that whole genera. So this is probably the ones that eventually became modern humans in the views of anthropology. And they're notable in the sense that they have many characteristics that are still similar to apes, but many characteristics that are still similar to modern humans. By the way, when I said apes right there, what I meant was non-human apes. Obviously, humans are a type of ape. You then have the progression from Australopithecines to Homo, to hominins that are very similar to modern Homo sapiens. And so you have a larger brain. At this point, we suddenly have brain sizes that are 500 cubic centimeters or larger. So brains are getting larger, teeth are getting smaller. Hominins, one of the things that tells us is that hominins are no longer relying on their teeth to do all the hard, heavy lifting of breaking apart meat and things like that. Instead, we're using things like projectile points, things like little stone axes to start cutting up meat for us, and we no longer need those fangs. Because if you think about it, something like huge fangs like a chimp has, that comes with its own cost, right? So a lot of times evolution is as much about getting rid of stuff that you don't need as it is about acquiring new stuff. And so if you don't need fangs, why invest the energy in them, right? It requires a whole lot more calcium to make a fang than it does just a normal tooth. It also requires your jaws to be shaped certain ways. It's got all sorts of costs associated with it. So humans lose the fang, get smaller teeth. We also get less prognathism, which your book said several times, and I'm like, they should really define that so people know what the crap they're talking about. What they're basically saying there is our jaw stopped jetting out like the way an Australopithecus did, or a chimp would, and instead becomes more and more human-like looking. We start to become larger beings. Hominins become larger beings during this phase, and then they also we start to see evidence in the archaeological record of things like fire and things like cooking, or sometimes direct evidence, sometimes very indirect evidence, but at least suspicions that this was happening. You have sort of the early to middle Homo species like habilis, heidelbergensis, Homo erectus from 2.5 million years ago to 200,000 years ago. Homo erectus is considered by many to be kind of the most direct ancestor for modern Homo sapiens. You then have the later Homo species from about 400,000 years ago to the present, and two of the most notable would be Homo neanderthal and Homo sapiens. And as I mentioned before, I don't know what that was about. Did not belong there. As I mentioned before, Neanderthal and Sapiens used to be thought of as different species, but there's been debates about that over time. Modern genetics, which among other things finds certain quote-unquote Neanderthal genetic markers in modern humans, suggests that Neanderthal and humans were interbreeding, and if two different species are able to interbreed, and not just interbreed, but produce fertile offspring, we generally recognize that they're not actually two separate species, and they're just two different kinds of the same species, because that's what a species is animals that can breed together and make fertile offspring. So Neanderthal is very possibly just another type of Homo sapiens, one that was a little bit shorter, one that had a slightly different facial structure, but a type of Homo sapiens. In any case, by about 250,000 years ago, we've sort of settled on modern Homo sapiens, and around this time, all the other hominin species have died out or are dying out, and you have either died out or bred into Homo sapiens, and now you have Homo sapiens, modern humans, the last and only remaining member of the hominins. As we look across this picture, what we see is several different tendencies over time. Bigger bodies, generally speaking, as this graph suggests, that wasn't always the case. Homo habilis is smaller than Australopithecus, but generally speaking, humans have gotten taller, hominins have gotten taller over time. We've gotten bigger brains over time, both relative and absolute. Again, both bigger brains overall and also bigger brains relative to our body, smaller teeth, a more vertical head with less of that jutting out jaw that you saw with the earliest hominids. Also, we lost ape-like hair. I'm putting it less hair, but in quotes because it's not even so much about the number of hair follicles as it is about the fact that our hair is a lot thinner and a lot lighter and a lot finer. So we're sometimes called the naked ape. Maybe I guess the thin-haired ape isn't quite as catchy, but we have, in a sense, less hair, if you want to think of it that way, than the Australopithecus. And I guess I would say less overall, yes, in a sense. Certainly less than like a chimpanzee. So hominids lose more and more hair over time. There's probably a lot of good reasons for that, probably the most notable of which is it allows for less heat collection if you're going to be running around the savannah hunting things. You know, it's different for a chimp or a gorilla who's in the middle of the forest, but if you're going to be running around the plains of the savannah trying to hunt or scavenge meat, you need to give a lot of serious thought to getting rid of your heat. And so one way to do that is to have less hair, or to have less thick hair. I put longer mullets here, just kidding, because the character at the end, the human that's drawn at the end, has like really long back hair. Anyways, I hope all of this has been an interesting lesson on hominid progression and evolution. And again, whatever your personal stance is on it, I think understanding it is really critical, and understanding kind of where humans are in terms of our hardware. However it came to be, whatever your stance on evolution, we can't debate sort of the basic biology that humans have certain very interesting tendencies that we share with a lot of other ape species, including how we eat and things like that, but also some things that are very, very different, such as how we move around. As we'll talk about for the rest of the course, we'll talk a lot about culture and different things, but we need to understand the basic sort of hardware system, the basic operating system that humans are running on, and that's what this was. So thank you very much.